Okay, lesson 1.5. We're already more than halfway done with the chapter, I think, or starting the second half anyways. So let's get started. We're going to learn a little bit more about angles and special types of relationships. So describe angle pair relationships. There's 1.5. So our objective today will be to identify complementary and supplementary angles. And so the natural essential question would be, how do you identify them? It's actually quite easy. If you can add to 180 or add to 90, you should be able to do this quite easily. Also, you'll notice at various places in my room there might be posters that remind you of what complementary angles are and what supplementary angles are. We're also going to talk about what's called a linear pair. So those three things we're going to basically cover today. And so there you have it. If the sum of two angles equals 90, then they're complementary angles. And if the angles add up to be 180 instead, they are supplementary. Now sometimes the angles are back to back or next to each other. And when they are next to each other, they're called adjacent. So let me show you what that would look like. So, on. All right, thank you. Do you know? Can you pass back some of these papers? Do you know these things?
Oh, I know.
Okay, so let me show you what I mean by what I was just now saying. Sometimes they might be adjacent or non-adjacent. So if you have an angle here and angle right here, let's say this one's 20 degrees. Okay, let's say this one over here is 70 degrees. If you add those two, you get 90, right? And so what it means is that these two angles are complementary, but they're also adjacent. And adjacent means that they're next to each other. And I like to think of them as like neighbors. Like if you go to your street, you know, there might be a house here and another house next to you. And usually there's a fence between the two houses, right? Well, that house is your boundary line, so to speak. Well, adjacent angles have a boundary line. They have a shared ray. And so this ray right here, I'm going to paint it black here, this one right in the middle, is the shared ray between both of these angles. It's kind of like a boundary line, property line, or whatever. So when this happens, we say that the angles are adjacent. Okay? And you can almost get what, you can almost guess what non-adjacent would be. Right? They're not together. Okay, so maybe you might have an angle here that's 50 degrees, okay, and you might have an angle over here that's 40 degrees, okay. Well, these two angles we would say are complementary. Complementary, it's with an E here. Complementary, okay, so they're complementary angles because they add up to be 90 degrees, right? Two of them. The same is true, you know, for supplementary angles. Sometimes the angles are adjacent, and you might have a situation here where this is 40 degrees here. In this case, this is 140 degrees, and then you'll notice that those two angles together add up to be 180. Okay, which means that those two angles are supplementary. So I'll write this like this, supplementary. Alright, now you'll notice this is a fairly long word, so you'll probably start seeing me abbreviate this one, right? Supplementary I'll probably write as S-U-P-P, and then I'll put in the angles like this, supplementary angles. Does that make sense? Everybody got it? And I'll start abbreviating this big word here. I'll just probably call them C-O-M-P, comp, angles like this, complementary angles. Okay, everybody good with that? Okay, so once again, if this is the case here where there's a shared property line, we say that the angles are adjacent. Those angles are adjacent. Adjacent just means next to each other. So the angles are next to each other. Okay, so let's go back to our lesson, and we'll just kind of march on through and do some more problems. And there's a picture also, a little bit better than the ones I was drawing. By the way, if they are adjacent and they are complementary, it means that there'll be a right angle in here. Because complementary means they add up to be 90, right? So notice there's always a right angle involved. And then in the non-adjacent situation, we don't write a right angle because they're not together. Okay, any questions so far? Kind of look okay? Kind of move on? All right. Where's mine? Oh, there we go. All right. Okay, so here's a little note here. Adjacent angles are two angles that share a common vertex and a side, but they have no common interior points. Well, let me just draw a picture of that real quick. So it's like what I said. You have a ray that's in the middle somewhere. Okay? And you'll notice all the interior points for this one are over here. Okay? For this angle over here on the top, they're all right there. The interior points for this one on the bottom are down here. Okay? Is there any interior point that's common to both? No. And that's what they're saying here. There's no common interior points. Okay? So that's another way of thinking of interior. There's this boundary that kind of separates everything. These red dots are up here, green ones are down here, so no common interior points. Okay, so that's another way of thinking of adjacent angles. Might help you out a little bit. Okay, so now you're going to have some simple questions on homework. If you can add, you'll be able to determine the answers to these questions. We need a pair of complementary angles. Well, that means the two angles need to add up to be complementary means 90, right? Right? So you see two angles that add up to, my guess is that it's this one right here and this one over here. All I'm doing is taking 58 and adding 32. And sure enough, that's equal to 90. So I have a pair of complementary angles. Now I just need to name them both. Okay, so right here, the ones that are complementary, this angle here is called angle CAB, right? The vertex goes in the middle, so it's got to be in the middle here. And the other angle, I'm going to use that little symbol for and, right? Symbol and. And this one over here, can I just call that angle S? Yeah, because it's by itself, right? This angle is by itself. There's no confusion. If I wanted to, I could call it angle S, but let me use a little bit better angle symbol. So I could call this angle S, okay? Okay, so you can use a single letter as long as it's not confusing. How about supplementary angles? You can almost guess, right? We need to name the two supplementary angles. Looks like to me this one, this big guy here has got to be included. So I'm going to say angle CAD. Is there another angle that adds up to 180 now? Remember, these guys have to add up to be 180. Okay, so let's see, 58. Looks like that angle over there again might work. 122 and 58. Sure enough, this adds up to be 180. So I found the correct pair. So again, I could call that one angle S. Any questions? I mean, this stuff, who could ever think that geometry would be so easy, right? Alright, for some odd reason, we like to make things more difficult by putting algebra in the problem. So you're going to see some of these problems as well where you have to solve some algebra ones. Okay, but before we get to that, let's try a couple other simple ones. You see a pair of complementary angles? Shouldn't take too long to find them, right? Name a pair of complementary angles. Okay, so let's see. My guess is, since this adds up to be 90, okay, I have to use smaller ones. I can't use that one. That one's too big already. And there's only 2 angles left, right? It doesn't make this very hard. Let's just check to see if they add up to be 80. And hopefully within 2 seconds you can say, well, yeah, duh, that adds up to be 80. Because 9 and 1 is 10. And 4 and 4 would give you 80. And 10 plus 80 is 90, right? Uh-huh. So they got to add up to be 90. So how about angle FGK? That's this one, right? Right there. And then this angle over here, we can call it and angle LKG. Okay, try to be a little bit careful with your writing here for the angle symbol. That could easily look like an L. Okay. Well, there's our complementary angles, and supplementary, pretty easy again. We just need to have them add up to be 180. So, I mean, if this is too hard, you might want to see the counselor. Yeah, need to be in a different class. So let's see here. We're just adding here, right? Do you think it's this one and this one, or this one and this one? Got to add up to be 180, right? Well, 41 and 131, the digit here, that one's digit adds up to 2, so that's definitely not going to work. This guy's not going to work. How about these two? If we take 131, we add 49. Sure enough, that's a 10. Give me an extra 1 there. That gives me an 8. 180. So there you have it. We have the 2 angles. How about angle LKG again? And it's supplement right here. And angle HGK. Okay. Alright. So that one's pretty easy. Now we're asking to see if you know what adjacent means. Okay. So let's be careful here. And you might take a moment and try to answer these on your own here. So it might be wise to pause the video. So the question is, are angles KGH, that's this angle right here, okay, and LKG is this angle down here, okay, are they adjacent? Okay, well, no one have an idea? Are they adjacent? Okay, so one of the things we realize is that they do have to have a boundary line that's shared. Like when I was drawing the street thingy, they have a house here and then a boundary, right? And then another house, right? So here's the thing. That requirement is met because they do have a shared boundary. This line right here is shared by both angles. Does that make sense? The green angle has it, the red angle has it. So they have a property line, so to speak. But there was a second fact that we saw on that previous slide. It said there can be no interior points that are common, right? Well, let's just draw in some interior points for the red angle. That the red angle? You guys okay? Because there's the red angle, right? What's the interior? Well, now let's draw on some green ones for the green angle. What do you notice? There's common ones, right? Since there are common interior points, these are not adjacent. Okay? So we would say not adjacent. Oh, by the way, this is a good way to abbreviate adjacent. Okay? Not adjacent angles, because they have common interior points. Okay, I'm going to abbreviate interior like that. Interior points. Okay. All right. How about this next one? Let's erase a little bit and see if we can answer this next question. How about these two angles? FGK. FGK is this one. FGK is this one. Okay. And FGH. FGH. Well, FGH is this one. Okay, well, if you take a look at the green angle and the red angle, they do have a common boundary. Okay, so again, let's look at our street example. If you have a common boundary, that's one requirement, right? You need to have a common boundary. Okay, so you'll notice that this angle up here, there's the common boundary right there. The green angle and the red angle both have that common boundary. But the second requirement is that they cannot have common interior points. So if we look at the red angle, we have a bunch of interior points. All over here, right? These are all the, I mean, of course, it'd take me a long time to draw them all in there, right? But if we look at the green angle has a bunch in here also. And notice there's some common ones in there. And so once again, we'd say no. And we'd say the same exact reason. Because they have some common interior points. Alright, so I think that's easy and straightforward. So let's move on. Okay, so these are just slightly harder, but if you can add, you should be able to do these, right? We're told that angle 1 is a complement of angle 2. Well, that means these two add up to be 90 degrees, right? And you know angle 1 is 68. So what's the other one? Angle 2, the measure of angle 2, you just need to find a number that adds up to 90. And so, you know this is 68, so it's like you need, what, 22? That would add up to be 90. So it'd be 20, angle 2, the measure of angle 2 is 22 degrees. Pretty easy stuff. This time, notice we use the word supplement. We say angle 3 is a supplement of angle 4. Okay? And so that means these both add up to be 180. Okay? Well, we know angle 4 is 56. So if you just simply subtract 56, you can find the measure of angle 3. Angle 3 must be what? There's 4 there, borrow here, 7, what, 12? 124? So if you could add or subtract, a lot of these problems are going to be easy. However, I'm pretty sure there's some algebra ones as well. Alright, here's a hokey problem. I'm not sure how many coaches go out there and draw a diagram of this soccer play here. And they go out and say, hey, guess what? This angle over here is x plus 2 and this one's 4x plus 8. I mean, that's just like stupid. So I agree the problem's hokey, but you're going to have a couple of these hokey problems. What we're told is that those two angles, you have one big one right here, and they are adjacent, and then you have this smaller one over here. We're told that they form supplementary angles. Well, that means they have to add up to be 180. So that gives you an equation. 4x plus 8. There's my first angle right there. So we add that to this one over here, x plus 2. They have to equal 180. Well, one thing you're going to find out here in just a little bit is that if two angles are adjacent and they're supplementary, you're going to notice that there's a line down here, right? And so in a sense, these two angles make up what we call a linear pair. And we're going to see that here in just a little bit. Anyway, coming back to here, we need to solve for x, and then we need to find the measures of these two angles. So we start out by adding those together, we get 5x. Add these two together, we get what, 10? We subtract 10, and we get 5x. Yes. I just put that on the third slot. Is equal to what? 170. And we simply divide by 5 and divide by 5 here. This gives me x is equal to 30. Let's see. I have 2 over 34. Okay, now a lot of people would stop right here because they're not paying attention, but only a bozo does that. Most of my students, they go and say, well, what were we asked to do? We're asked to find out those two measures. And this can be easy because, see, if I take this 34 and I substitute in for x right there, I find out that this angle is 36 degrees, right? Now, you don't have to, you could plug this in right here, but you could also say, hey, they have to add up to be 180. So what number do I add here to get 180? You might say, well, I have to have at least 100. And let's see, I need another 44. 144, I think. If you add those two, right, don't you get 180? So this stuff's not terribly hard. Okay, so what we would say is that the measure of angle BCE, that's this one, is equal to 144. And the measure of angle ECD is equal to 36. And there you have it. So even if it's algebra, hopefully you can handle this algebra. It's a pretty basic algebra here. Okay, we're not going to try it. We're going to move on. So now we're going to talk about a linear pair. The way you determine a linear pair, it almost gives this away here. There's going to be always a line involved. And you're going to have adjacent angles. So you have to have a common boundary line. So start out by having a line here, like this. And we'll put in the common boundary line. Call this angle 1 and 2. And I think you agree that angles 1 and 2 have to be supplementary because they form a line right here. But they're also what we call a linear pair. Hopefully you understand a pair involves two items, right? So if you have like a third angle in here, then we don't call it a linear pair anymore because there's three angles in here. Okay, so what you could say is that angle 1 and then this big angle over here form a linear pair. Anyhow, they need to have a common side. And notice how our book describes it. It says they're made up of opposite rays. Well, here's a ray going this way. Let me draw that in light green. You have a ray going this way. Okay, then you have a ray going in the opposite direction. They have a common endpoint. Okay. Well, hopefully that's not too hard. Now here's something. Every linear pair will be supplementary. And that's because you know about your angles, right? A straight line forms a straight angle, right? Which gives us 180 degrees. And so if you have a ray in here that makes up two adjacent angles, the angle addition postulate says angle 1 and angle 2 have to add together to give you the big angle. So that should be fairly obvious. Every linear pair, the angles there will be supplementary. Alright, so we've drawn an example here. There's one more type of special angles here. And this one, I've always found it real easy to get this, but A lot of people have trouble drawing this, and a good exercise is to like pause the video here and see if you can draw it based on this definition. It says two angles are vertical angles if their sides form two pairs of opposite rays. Well, that sounds confusing to be quite honest, but let me just show you real quick. Vertical angles. There's one line. Then you draw a second line. Like that. Okay, the vertical angles are these, the green ones. We would say these two angles are vertical angles. And you also might think of these red ones are vertical angles. Okay? Now, let's go back and see if this definition works. Okay? So, two angles are vertical angles if their sides form two pairs of opposite rays. Well, let's take a look here. Here's one side. Okay? And notice it has an opposite ray going over here. So, there's the two opposite rays there. And then you have this other side over here. Alright? And it has an opposite ray on its side also. So there's the two opposite rays, and there's the two opposite rays over here. And so you have vertical angles. To me, that's kind of a strange way of saying it, but it's true. It works. Anyhow, you want to be able to recognize all of our special angles. We have 4 of them now. We have complementary angles, we have supplementary angles, we have a linear pair, and now finally we have vertical angles. So angles 3 and 6 are vertical angles, 3 and 4 are a linear pair, 4 and 5 are vertical angles, and 5 and 6 are a linear pair. Alright, here's a good exercise to try. If you're watching this at home, I would pause the video and see if you can answer these questions. This is a very good exercise. And so, you should try to determine, are there any linear pairs in here? Remember, a linear pair is two angles only that form a straight line. Must be an adjacent angle in there. And so, see if you can find a linear pair. Okay, well, at home you'd pause the video, but do you see angles 4 and 5 here? There's a straight line going this way, right? It's always easy for me because you'll see two angles that form a straight line. You see, there's the straight line. So how about angle 4, and angle 5? Do you guys see any other linear pairs in there? Well, I see these 3 angles would work. They add up, but that's not a linear pair because a linear pair has 2 angles only. How about vertical angles? Vertical angles. Well, in order to have vertical angles, first thing you need to do is look for intersecting. You need 2 lines that intersect. So this one is not a line. It doesn't continue over here, you see. That one does not continue. Okay, so since that one doesn't really continue, it's adding some confusion to the picture. However, I do see 2 intersecting lines. One's here and one's here. So do you see angles 1 and 5? 1 and 5. Angles 1 and angle 5. Those would be considered vertical angles. Okay? So there you have it. Let's move on. Oh, whoops. Sorry, let's back up just. Alright, so you guys, here's a little algebraic problem. First of all, we're told that they form a linear pair. You automatically know then that they are supplementary. They are supplementary angles. Okay, and supplementary means they add up to be 180. So whatever angles we read about, they have to add up. So I'm going to go ahead and put a plus sign, and I'm going to put equals 180. Okay, I know that so far. It says the measure of one angle is 5 times the measure of the other. So you can let like angle 1 be equal to x. Angle 2, you're going to say it's 5 times bigger. So that would be 5x, right? And so now you just need to add them. X plus 5x equals 180. Add these two together, I get 6x. I'm almost done, don't worry. And now I divide by 6, I get x is equal to 30. And what's the other one? This would be 5 times 30, which gives me 150. So there you have it. Let's call this the measure. Okay, so you might have some of those on the homework as well. And we're going to skip this one. And then we're kind of done here.